What's up, math scholars? Mrs. Harp here. I'm recording this lesson before class as a just in case. I'm getting nervous I'll get sick and have to go home today because my daughter's at home sick. But we'll see. I hope I make it through the day. Let's start with this warm-up. We're going to be finding patterns in this lesson and trying to write equations to fit the patterns. So I just thought it'd be fun to practice finding some patterns. It says find the next two numbers in the pattern. 3, 8, 15, 24. So can you figure out what's going on there? So I was thinking about a couple things, like are they multiplying by something? Are they adding something? What popped into my head is from 3 to 8 they add 5. From 8 to 15 they add 7. From 15 to 24 they add 9. So I'm guessing we'll just want to add 11 to get to our next term. That would be 35. And then let's add 13 to get to our next term, 48. Okay. All right, 1, 6, 11, 16. What would come next? It's as easy as adding 5 each time. So 16 plus 5 is 21, and 21 plus 5 is 26. That one would be called linear because they're adding a constant amount each time. All right, how about 1, 2, 4, 8? What's happening there? I should move this so you can watch my dancing shamrocks. That makes your day happy. Oh my gosh, they're playing instruments. It's like a dancing shamrock band. How convenient the band leaves for Ireland today. Good timing. All right, so looks like they're doubling each time. If I double 1, I get 2. If I double 2, I get 4. And then 8, and then 16 would be next, and 32 would be last. All right. So today we are learning about sequences, day 1. A sequence would just be a list of numbers that would have some sort of pattern to it. So at any time, if I get going too fast, pause the video, like always, rewind. Hopefully you're having a happy day today. All right, a sequence, a function whose domain is the set of consecutive integers. A lot of times today you'll be seeing me make a chart where the domain would be just the numbers 1, 2, 3, 4, and 5. And then the range would be the actual terms in the sequence. That very last warm-up problem we had. 1 was the first term of the sequence. 2 was the second term of the sequence. 4 was the third term of the sequence. 8 was the fourth term of the sequence. I don't know why that line is there. And then 16 was the fifth term of the sequence. The domain is the integers, the consecutive integers, but the range is the actual numbers in the sequence. It says a sequence can be defined by an equation or a rule. We have two different types of sequences we'll be looking at today, finite and infinite. Finite would have a limited number of terms. And infinite would continue on forever, honestly. So it would continue without stopping. So I guess I'll give you an example of each. Finite would be 2, 4, 6, 8, stop, and they'd probably put a period there to let you know they're stopping. And then infinite would be 2, 4, 6, 8, 10, dot, 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 dot. So you'll see that dot, 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 dot when it is an infinite sequence. All right, write the first 6 terms of the sequence. So again, I am going to do this in chart form just to keep ourselves organized. That way we can see our domain and our range, and eventually we can add up our things in the right column. That'll be tomorrow. So write the first 6 terms, term 1, term 2, term 3, term 4, term 5, and term 6. It's as easy as making a T-chart back when we were doing graphing. So you'll take your 1, put it in for n. That would be 2 times 1 plus 5. That would give you term 1. In other words, A1 it's called. So term 1, 2 times 1 plus 5 would be 7. Let's go ahead and find term 2. That would be called A2 by doing 2 times 2 plus 5. So that would be 9. I'm going to pause the video right now, and I want you to fill out the rest of the chart yourself. All right, how did that go? Check your values. It should go 7, 9, 11, 13, 15, and 17. That would be a finite sequence since I stopped. If I want to make it infinite, I could keep on going forever. All right, let's write out the first 6 terms of this sequence. So my column would be n and f of n, because that's how they set it up. 1, 2, 3, 4, 5, 6. So to find f of 1, you'll put a 1 in for n. Put that negative around the parentheses for sure. But it's basically negative 3 to the 0 power, and anything to the 0 power would equal 1. To do f of 2, I put a 2 in place of n. That would end up being negative 3 to the first power, so it would be a negative 3. And I go ahead and click pause and allow you to fill out the rest of the chart all by yourself. All right, go ahead and check. It should go 1, negative 3, 9, negative 27, 81, negative 243. So it's like super cool how it oscillates back and forth from positives to negatives. Right? Our next one, we're going to find our terms, our first 6 terms, but then we're going to graph the sequence. That will be neat. All right, so make myself a little chart. I have a lot of space here. Do you mind if I just do a horizontal chart? Hopefully that doesn't bother you. I'll do my first 6 terms. 1, 2, 3, 4, 5, 6, and then here will be my actual terms. When I put a 1 in for n, I would do 1 plus 4 and get 5. Put a 2 in for n and get 6, 7, excuse me, 8, 9, and 10. Now these are just coordinates you will graph. So you will go to 1, 5 on the graph and make yourself a dot. You'll go to 2, 6 on the graph, make a dot. 3 is at 7, 4 is at 8, 5 is at 9, and 6 is at 10. Now, this is a discrete data set. You would not want to connect these dots because we don't have anything in between. We don't have like a term 1.1. Okay, so it's just these integers only. Your graph will just be dots. All right, we're going to move on to the more challenging section of the lesson where you are on your own to find the equation. Sometimes finding the equation is easy, sometimes much, much harder, so just stay patient and try different things, and hopefully you'll figure out the equation. All right, so my advice is definitely take your terms and put them in chart form. So term 1 is negative 1 in this case, term 2 is negative 8, term 3 is negative 27, and term 4 is negative 64. It is infinite, it has that dot, dot, dot. Actually, now that I see the instructions, it says describe the pattern, write the next term, and write a rule for the nth term of the sequence. So let me scroll down so we have a little more space to write down one more term. Do you see the pattern developing? All right, sorry, I paused because my phone rang. We're going down, looking for a pattern happening here, and seeing if we can see what's developing. Any ideas? It has to do with powers, that's my hint. 1 to the negative 1 to the third power would equal negative 1. Negative 2 to the third power would equal negative 8. It's not the easiest pattern to see, but to get our next term, we would do negative 5 to the third power. That would be that negative 125. So to write it out in equation form, it will be negative n to the third power. Right, so there are exponents involved in this one. All right, let's try one more where we're trying to find the pattern. So we're going to write the next term, and we're going to write out the rule. 0, 2, 6, 12. So my first term is 0, my second term is 2, my third term is 6, my fourth term is 12. What's my fifth term? Definitely not the easiest one to see. I guess I can give you a hint. There's squaring involved, and there's subtracting involved. Go ahead and try to figure it out for a second or two here. Do you have any ideas? It's n squared minus 2. So let's look at 2, for example. 2 squared would be 4, and 4 minus 2 is 2. 3 squared would be 9, minus 3 would be 6. So 4 squared is 16, minus 4 is 12. So to get my next one, I would do 5 squared, which is 25, and subtract off 5, and that'd be 20. So to write that in equation form, n squared minus n. Now, they're not all going to be that challenging, but it's good to see the challenging ones. I hope you do the easier ones easier. All right, so your homework is a worksheet, and it is actually here on the notes. So if you go into Polaris and pull up the notes, you'll be able to see it. And I will see you later. Thanks for watching.